We're going to work with some word problems here with Algebra 2, and it's all with exponents. So when we look at this type of problem, what we're going to do is have a savings account that receives 5% interest per year, and what we're going to do is deposit $400 into this account at the beginning. So what we have going on is basically getting you to think about percentages and how well, hopefully you have some sort of experience with this, that you would change that percent to a decimal, because remember, a percent, like the word percent literally means out of 100. Per means out of, cent, well, there's 100 cents in a dollar. So it's 5 out of 100. That's why it always works out that you can just move that decimal over twice. There. Yeah, so if you just do the quick math on that, you can even type it into a calculator. I'm okay with that. It's increasing by $20. And if you think about it from a standpoint of what you've probably done in previous math classes, is then you have to add that $20 to the 400 that you started with. So at the end of 1 year, you're at $420. And what you really did, and this is how I prefer doing the problem, is, let me emphasize this piece, is what you could have done is divided divide 400 out of that. Maybe I should show that step. So let me go with that 400 over 20, and 20 I should say, and divide each piece by 400. Now you wouldn't know to do this until your teacher says to. And what I'm really doing is I'm factoring out the 400. And something divided by itself is 1, and 20 divided by 400 is 0.05. You could even solve this problem up here by dividing both sides by 0.05. We'll divide by 400, I should say, and you'd get 0.05. So the thought process is, what you could do is actually create your own equation. Kind of want to do it in part E already, that you could create an equation for the savings account after time is equal to the initial amount times 1 plus 0.05 to the t power. And the reason why is because after 2 years of doing this savings account, well, maybe I should pull up a calculator. How about that? I'll pull up a calculator real quick and just show you, well, $400 times 0.05, you're making $20. Well, the next year you have $420, that's getting 5% interest. You're actually making more money. So after 2 years of making 5% interest, you actually have 420 plus $21. So after 2 years, you have not just another $20, but another $21. And really what's happening is you're taking this equation, let me write it right here, and I think you could do 1 plus 0.05 in your head, to the second power, and that's how you get that answer. So the reason why I'm showing you this is because it'll save you some time, that after 10 years, because that's what they asked for here, you're actually going to have $651.56. I already forgot what the number was. 56 cents. And that's a common misconception that people have, is that they think, oh, well, if I only made $20 in 1 year, well, over 10 years, it's going to be $200, right? 20 times 10. But you're actually shorting yourself $51, which I get a lot of students are like, well, what's the big deal of $51 over 10 years? Well, imagine instead of $400, maybe it was $4 million in the account. Well, then you're not just shorting yourself $50, it'd be like $50,000. So a pretty big deal. And what you could do is you can actually use a calculator now and think about how long it would take for $400 to double. And in other words, we're trying to get up to $800, which at least it took us 10 years to get to $650. So I think you should guess a number bigger than 10. But like the calculator says, oops, still have stuff in here from before, you can use your calculator and the table command. So I just type that into y equals and go to my table, and I can go down, oh, there's 10 years. It looks like it's taking about 15 years. I'd be fine if you said 14 years, but technically at 14 years you're not there yet. So I would say up to 15 years to get your $400 to more than double. It was like 831. I already forgot what the dollar was. And 57 cents. So pretty interesting stuff. So what we're going to formally do now is actually have an equation for things that increase. Now, not every problem tells you that it's increasing, but you want to look for certain words, whether it's increase, grow, growth, populations could increase in size. But what's important about this is the plus sign in the problem. There's a plus sign in there. And I know some people get confused because they see Q here and a Q here. It's just saying like, hey, here's your starting amount. That's what Q subscript 0 is when T equals 0. And T represents time. A lot of times we want to talk about years for time. Other times we want to talk about weeks, days, hours. So every problem is a little bit different. And then you can see the decimal form of the percentage. So in this problem, we have a savings account, so we're using this formula. And they set it up really nicely for you. It's $250 is the starting amount, that's what invested is. You want to have 1 plus your 3%, but you have to change that percent to a decimal, and then to the T power. And I don't know what else to say besides it's option 2 is the correct answer. And what we have going on is more of the same thing. And we see how they talk about increasing. So we have Fruit Bud New York is increasing at a pace of 2.5% per year. And then they want to figure out the future population. And in 2005, it had a population of 6,500 residents. So this 2005, I'm going to have it as T equals 0. So if I'm trying to come up with a P equation, population, we're starting at 6,500. And then 1 plus, remember to change that 2.5% to 0.025 to the T power. And so what we can do is we can come up with an equation using that formula and talk about what the population will be in 50 years since 2005, so 2055. And you're going to see me go straight to a calculator. 6,500, 1.025 to the x power. And all I'm going to do is go to my table, because this might give you a rough estimate at, we started at 6,500, so 0, 6,500, just going to lamely put that on my graph. But then when I jump to 50, now you could scroll down or you could hit second window and change your table setting just to go up to, I don't know, make it go up to 45. Might save you some time. But you can see in the year 50, in 2055, we're at 22,341. And I don't like to use commas because then I might confuse you. 341. And it wouldn't make any sense to have a decimal of a person, so I'm going to stop it right there. But the reason why I like to go to the table first is then I could, before going to the graph, I could just make my window. Now, I'm not going to mess with that too much. Maybe go from -10 to 60. But then make my y values go from 6,500, the starting amount, all the way up to, I'll just make it 23,000. You can count by hundreds or whatever you really feel like. But if you look at your graph, you can see that it doesn't just grow, but it has what's called exponential growth, which means it curves. It looks something like that. And we can use this to predict the number in 2010. Now remember, it was years since 2005, so that would be t equals 5. So it's up to you. Do you want to just go and type into the equation, or would you rather go back to your table? Now let's go to the window and just go back to t equals 5. There you go. So you can see that the population is about 7,354. And I'd be fine if you wrote as p of 5 as about 7,354. And what's nice about this as well is when we get to a population really close to 10,000, I can just scroll on my table instead of just guessing and checking. It looks like about the year 18. About t is about 18, which when you add 2005 to it, that's about the year 2023. And it wants you to show that mark on your graph. Basically what it's saying is, okay, well, what if you made a population of 10,000? Then it would be about year 18. And I did not do my graph very well, so that doesn't really look right, but that's okay. Okay, so here's another problem where we're talking about the flu is increasing at a rate. So that's where we're going to have this 1 plus 0.12. On Monday, there's 56 students with the flu. And they want to know the number of students who had the flu on Friday morning. Well, how many days? Well, it says at the beginning of Monday. So that would be like year 0. And this would be Friday morning. So you have to be careful because Tuesday would represent 1, Wednesday would represent 2, Thursday would represent 3. I would say Friday would represent 4. So that's how I would type into the calculator. Not sure if that would make a huge difference. So about 88 is the answer I would come up with. I'm not sure if they even have an option for the day 5. Kind of curious now. Change that 4 to a 5. Yeah, I don't think they have an option for 99. So yeah, let's come into that one. And then here's another one where we have population of rabbits. There's 45 rabbits, increasing 8% per year. 0.08. And we don't know what the t is, but what we could do is we could set up an equation and see when it equals 90. So let's do that real quick. Y equals 45 and then 1.08. And I'm just going to go to my table. I want to see when it's as close as possible to 90. It looks like 9 or 10. It looks like 9. And you should be ready for the homework now.